Good day, grade 10s. In this lesson, we're learning about current. So, current is defined as the rate of flow of charge. In other words, a measure of how much charge passes a certain point in 1 second. The equation for it is I is equal to Q over 2, where I is current in amperes, the current is measured in amperes, Q is charge in coulombs, and T is time in seconds. Please note that these are the SI units. So 1 ampere can therefore be defined as 1 coulomb per second. So let's look at an example. What current passes through a lamp if 30 coulombs of charge flows in 5 seconds? So if we use the equation I is equal to Q over T, which we can use, then what are we going to get? We know that I is equal to Q over T. Our Q is how much? It is 30 coulombs. So that is going to be 30. Our time conveniently is already in seconds, so it's 30 divided by 5, which is 6 amperes. 6 amperes. So that's a nice easy example here. Right, conventional current. Conventional current assumes that the current flows from the positive terminal of the battery to the negative. We indicate this with arrows. So sometimes they'll ask you to draw a graph, not to draw a graph, to draw a circuit, and they'll ask you to indicate the conventional current. And if you look over here carefully, you can see that this is the positive end of the battery. We know this because it's a long one. And the conventional current will be traveling from positive to negative. Okay, so that is the conventional current. Real current is called electron flow, and this is the direction that the electrons actually flow, and they flow from the negative terminal to the positive terminal. So why do we need to know this? Later on, many years from now, you'll actually need to use that. But by convention, we said that charge flows from positive to negative, and we use that with all our rules. So that's nice and easy. So electricity is the flow of electrons around a circuit. It always flows from the negative terminal. The electrons flow from the negative terminal to the positive terminal because the positive terminal attracts the negative electrons. But by convention, we say it travels from the positive to the negative. So what do we use to measure our current? And obviously we measure with using an ammeter. Now ammeters have got a very low resistance compared to the voltmeters. Remember the voltmeters, very high resistance. Ammeters, very low resistance, and therefore are connected in series. So how do we draw an ammeter? And here we go again with my horrible drawings. So here is your battery, and there's your circuit, and there is your light bulb. And this time I have to make space for an ammeter because the ammeter is actually going to be part of my circuit, and that is how we draw it. So we draw it within the circuit. So the current will be flowing, the conventional current in this case will be flowing from the positive through to the negative, so it'll be going around in that direction.